Hi, welcome to this video on my Arduino Mega2560 and some electronics. In the last video I tried to get these two motors running at the same time, and I tried that using the RLC circuits, which are in parallel. Each motor is connected to one of those circuits, and unfortunately I haven't succeeded until now. What I do manage is to get the LED burning, and only this motor runs. Which brings me to the question, is the voltage enough to get two motors running anyway? To get that solved, I have taken another motor and will connect that to this transistor and see if that motor will run together with either one of these. So I will just connect this motor and then it should be up and running soon. And I hope, let me shove the board a little bit up, and this way you should be able to see this gear. Well, at least this motor runs, this one not yet. And this motor once again has to be given an advantage or some push, but anyway it runs. And the other motor still doesn't run. And since this is a parallel circuit, I wonder if making it not parallel makes the other one running as well. So this one will it run when I put it on a different situation. Apparently two motors can run, so let's find out. And obviously the first motor, it runs again. This is also something remarkable. Because this motor runs nice and slow and without hesitation, while this motor obviously let's turn it up a bit. This runs it needs some persuasion. But it works. So let's see if I can get the circuits divided and running. And then I'm talking of course on the RLC circuits. To make it a little bit visible, this is the schematics, and these are the RLC circuits in parallel. And what I need to do is add another voltage source and put them all in a different so I take electrical constant voltage, because that is what we're dealing with. Rotate, another rotate. This is what we want. Then delete. Let's delete this one. This I can easily, or should be easily, to connect yes to the ground, and this one is connected to this RLC circuit, so now they are no longer in parallel. And let's save it. Save as. Version 3, and let's make it an XCOS extension. So this is version 3. I'll just run it. Yes. There's one slight thing I forgot. But let me just wait until it is running. One detail, because this one is 5 volts and I forgot to put this one, which is 5 volts as well. Save and go again. Yes. And what you do see here is that one of the voltages is actually dropping faster, so that is not changed, but it is no longer in parallel. So now I have to change the source code and see if that solves the matter. Source code, of course, has to do with adding new wiring to the deparalleled RLC circuit. Anyway, these graphics are nice, and let's keep this. Then this one, this is the source code, and I have to use, of course, an additional output pin
and the current one is used by output 2, which is this one, and I still can use output 4. So let's do that. Of course I have to use another, am I reasoning correctly? I do think so. Not necessarily, because output pin 4, this one is going to 2. Anyway, I have 4 available, so I have to make new new connections anyway. I just enter a new one, making that this 6, and I create this for RLC, whatever. This is of course for the old one, so I have to change the source code a little bit and do some wiring, and that's gonna take some time, so that's it for this screencast. See you soon. And the only thing I actually had to do was create another analog out pin, which is 4. Then put it in here with the same value, and then make it compile and run. Compiling, uploading, done uploading. So now the new program is on the Arduino, and let's see how it runs.
So I have created another jump wire set. I shifted the pin of this resistor a little, one row to the left. The jump wire is added. Then here of course another jump wire, which is not going to work, I notice. But this is going to pin 4, and this should be right here. So I need to reroute this jump wire a little bit. Alright, let's see if I can make that work nicely. it's isolated anyway. On the other side of this pin. So this wire must be rerouted a bit. And with care can even more be rerouted. That's the maximum length. The wiring is a little bit not steady, and I do need this wire to be parallel here, and that will be a challenge, but let's try it anyway. See, now it's connected fully. And now let's see how it all works. That is 1, 2. And bizarre enough, this one still refuses to run. So the question is, why is that the case? So the new output is working because this one is working, but why is that one not working? Good question, and has to be solved. And while the parallelization, or better said, no longer parallelization obviously has not paid off. The question remains, why does this motor not work? At this moment I replaced this LED by a yellow jump wire, but that should have no effect at all. This works. This doesn't work at all, which is very strange indeed. I've tested earlier with smaller capacity for this capacitor, but that should not matter. So with this mystery, I do think I'll end this. This motor obviously works. This motor obviously works. And with the deparallelization not being the solution, I'll have to look further. So right now 3 motors, and apparently the circuit can have it. The third motor, still a question, so to be continued.